Hello and welcome to EC Electronics. So in this video we are going to discuss about the types of errors in instruments. So we are discussing the various topics from electronic instrument and measurement subject. In this video we will be discussing about the errors, the type of errors in instrument, and also we will be doing a lot of questions, that is numerical questions from this error session. It is a very important area, especially for competitive examinations. So if you are preparing for any competitive examinations, you should watch this video till the end. And if you found the video useful, please don't forget to like, share and subscribe. So in today's video, we are going to discuss about errors in instruments. We'll be discussing the all major categories of errors and we'll be doing the numerical questions also. Okay, so this area or topic is very important for competitive examinations, especially for all the diploma exams. Okay, so before going into the category of errors, what is actually an error? Error means some unwanted things or unwanted changes happening to the measurement is called error. That can be due to the observer or due to the instrument or the condition in which we are taking the measurement. Okay, so that is the way of happening of errors, or that is a definition of errors. Now the errors can be classified as various categories. First one is static error. Static error means it is actually the difference between the true value and the measured value. So in generally, if there is some variations happening in the reading, we can call it as a static error. Now we will be doing problems on this topic or the static errors. Okay, so that is one classification. Then second one is gross error. Gross error means the error that is happening due to the problems with the observer. Sometimes he may read it wrong, or sometimes due to the carelessness. So these type of errors are called gross error. We'll discuss about all of this in detail. Okay, so that is gross error. Then systematic error means errors happening to the measured value is called systematic error. That can be due to instrument or environment or due to the observation. Okay, then next category is limiting or relative error. So how much deviation there can be in the measurement, that is indicated with the help of limiting and relative error. We will be doing numerical questions or problems from this area, and also we will study the equations. So when we are doing the resistance problem, we know that there is some tolerance value for all the resistors, right? So when we are taking into consideration the errors, we have to be knowing the equations. Okay, so that all things come under this area. We'll discuss about all these things in detail. Okay, so that is the next classification. The last one is random errors. So random errors is because of the random things happening in the measurement environment. That can be sudden change in pressure or humidity or anything. Okay, so that is the last category of errors. Now first we are going to discuss about the static errors, and also we'll be doing the numerical questions. Okay, so let's see what is static error. So the first type of error that we are going to see is static error. And the static error is defined as static error is equal to AM minus AT, where AM is your measured value and AT is your true value. So it is the difference between the measured value and the true value. Okay, now the true value can be defined as true value equal to measured value plus static correction. Now, this static correction is the inverse means it is the sign negative of your static error. So, if your static error is positive, if it is positive, means your correction will be negative. Okay. So, whatever there is an error, that much you are going to correct. So it will be opposite in sign, not inverse, it is the opposite sign. Okay, so static error, if it is positive, then that much in magnitude and its opposite sign will be your correction. We'll get a clear idea with the help of these two examples. So we are going to do two examples on finding static error. So just know that static error is the difference between the measured value and the true value. Okay, so the first question is, a meter read 127.5 volt. True value is 127.43 volt. Calculate the static error. So static error is equal to, the simple equation we have to use, static error is equal to AM minus AT. Okay, so here what is AM? It is the measured 127.5 minus 127.43. This is the measured, this is the true value. So the error will be 0.07 volt. Okay. Now, if static error is this, what is static correction? Static correction will be minus 0.07 volt will be the static correction. But it is not asked in the question. Here we are going to apply the second equation. The question is, thermometer read 95.45 degrees Celsius and static correction given in the curve is minus 0.08 degrees Celsius. Determine the true value. So you have to use this equation. True value is equal to measured value plus correction. So true value equal to, I'm going to directly apply the values. True value we have to find, that is equal to, this is the measured value 95.45 plus correction. Correction is minus, it is a negative value. So it is plus minus, or you can simply write it as minus 0.08. Okay, the value you will be getting is 95.37 degrees Celsius will be your true value. Okay, so just apply this concept, that is the concept of static correction in this question. You will be getting the true value as this. That is, if you are in this question, if you are going to find the true value, okay, what will be the true value? True value is equal to the measured value plus correction, which is this much. So 127.5 minus 0.07 will be 127.43. So just know that whatever error you are getting, its sign change will be the correction. That is the relation between static error and the static correction. If you are getting static error as positive 0.07 volt, your correction will be negative 0.07 volt. Okay, so this is the concept of static error. The next classification of error is limiting error and relative limiting error. Okay, so limiting error means it is the maximum deviation of the component value from the nominal value. How much maximum deviation can occur from the nominal value is called limiting error, and it is represented using epsilon 0 and also sometimes represented as delta A. Okay, so these two representations can be used for the limiting error. Okay, then relative limiting error means it is the ratio of this limiting error to the specified value. How much is the ratio between the limiting error and a given value? That is called relative limiting error and is represented as epsilon r. Okay, so this will be in percentage. The relative limiting error will be in percentage, and it is given as epsilon r equal to limiting error by the given value. Now we are going to see the relative limiting error or the relative error when the quantities are combined in various ways. That is, when two quantities are added, when two quantities are subtracted, and when we are taking the product of two quantities, how the relative error is going to come. What are the equations we are going to see. Now these equations are very, very important, especially when we are doing questions connected to the resistance problem. There we apply the series combination, the parallel combination, all those things, right? And also we'll be doing problems connected with the powers. There also the errors can happen, right? So in that cases, we'll have to require or we have to use these equations. Okay, so let's see the relative error when we are combining the quantities in various ways. So next we are going to see the relative error for various combinations. So these combinations can be the combinations when we apply resistance equations or power equation. There is power equations like P equal to V into I, or I square R, or V square by R. So in all these cases, we have to attempt questions on calculating errors, right? So in those cases, we require these equations. So consider that the first case, capital X is the equivalent value of x1 plus x2. Now this x1 and x2 is having some errors. So how will the resultant quantity will get affected with these errors? How is the errors adding up? Is this equation same? And this equation is the equation for relative error. Okay, so we are going to actually calculate the relative error. So just know that capital X is equal to x1 plus x2, where x1 is any component value or x2 is any component value, and delta x1 is the limiting error of x1 and delta x2 is the limiting error of x2. For example, when we are taking one resistance, consider that the measurement of that resistance value is involved with this much of error. Then in that case, x1 is that original resistance value and delta x1 is the error involved. Okay, so that much is the variables indicating. So capital X is the resultant of x1 plus x2. So just consider that we are going to add two resistance values that are in series combination. So it will be x1 plus x2. The error of x1 is delta x1, error of x2 is delta x2. So how the relative error is coming is this equation. So epsilon r is equal to plus or minus x1 by capital X into delta x1 by x1 plus x2 by capital X into delta x2 by x2. So here, just as we said in the definition, relative limiting error is the ratio of limiting error to the value. So this is limiting error and this is the value that will get added to this x1 by x plus same for x2. Okay, so this is how the error is happening when we are adding x1 and x2. Now, next is the case in which we are going to take the difference between the two quantities. So the resultant is, or the equivalent is x1 minus x2. In that case, the same as the previous case, epsilon r is exactly the same equation as the addition. So the error will be always getting added. Okay. So epsilon r is equal to plus or minus x1 by capital X into delta x1 by x1 plus x2 by capital X into delta x2 by x2. So these two equations are same. Then third case, when we are going to take the product of the two quantities, x equal to x1 into x2. So in that case, the relative limiting error is epsilon r equal to plus or minus delta x1 by x1 plus delta x2 by x2. Fourth case, when we are going to take the division of these two quantities, capital X equal to x1 by x2. Epsilon r equal to plus or minus delta x1 by x1 plus delta x2 by x2. Again, these two equations are same. Then the last case we are going to discuss is when we are going to take the nth power of a quantity, that is capital X is equal to x raised to n. Then the relative limiting error is plus or minus n into limiting error of x by x. Okay, so these are the equations in which we find the relative error or the relative limiting error. Now let's do a small problem on finding that is applying this equation. Okay. So next we are going to see a problem on finding the relative limiting error. The question is the limiting error of power is plus or minus 1.5% and current is plus or minus 1%. Find the relative limiting error in resistance calculated. So we are going to find the resistance value using power and current. What is the equation? Power P is equal to I squared R. Or we can write R is equal to, we have to find resistance, the relative limiting error in resistance, which is equal to P by I square. Okay, so this is applying two things. One is division and second one is power. Okay, so the equation will be plus or minus delta P by P plus 2 into delta I by I. Okay, so here this is given, the limiting error is given in percentage. So this is nothing but the relative error. So this quantities is directly given to you. Delta P by P and delta I by I is given. So that is nothing but the relative error in power and relative limiting error in the current. So you have to directly apply into this equation and find the value. So delta P by P is given to you, which is 1.5. Then delta I by I is given, which is 1. So you will be getting plus or minus 1.5 plus 2. That is plus or minus 3.5%. So since these two values are given in percentage directly, you can directly apply into this equation. That is delta P by P is given. So we have discussed that while explaining the relative limiting error, that those values are actually in percentage. So here, since the percentage values are directly given, you can apply here. Okay, 1.5 plus 2 into 1%. So you'll be getting plus or minus 3.5% is the relative limiting error in the resistance calculated. So these two are actually relative errors in power and current. Okay. So the answer here is plus or minus 3.5%. So the third classification of error is actually the error due to the observer. Okay. So the error is happening because of the person who is taking the reading has done something wrong. So that is the third classification. The first two classification were actually we are actually discussing based on the questions, that it is more problematic. But from here onwards, we'll be discussing more on theory. Okay. So the third one is gross error. So the errors can be due to the error in reading. Consider that we are going to measure some values. For example, we are going to use a voltmeter or any meters. But before the meter is actually settling to the normal value or the steady value, we are going to make the measurement. So there can be some errors because the instrument has not reached its steady value before we are actually making the measurement. So in that case, we'll get a wrong reading only. So the instrument has to be in the steady state, only then it will read the correct value, right? So if such an error is happening, that is called a gross error. Again, second reason can be mistake while recording. That is, he has read the value correct, but while recording or writing it down, there was some mistake. So that is the second reason which can lead to gross error. Third one is calculation has gone wrong. The measured value is actually right. He has written it also correctly, but while calculating, some values he have put as wrong. So the calculations can go wrong. So these are the three types of or three reasons which can cause gross error, or three types which can lead to gross error. An example is parallax. Means when we are going to read some values, for example, some fluid level or taking a reading, we are going to view from the steady point, or we are going to shift our viewpoint to upward or downward. So for these 3 points, the reading we are going to take can be 3 values, right? So in which position we are going to make the reading? Are we going to look from here or here or here? The 3 readings can be varied. Okay. So we have to first adjust our viewpoint correct and then make the correct measurement. Only then we can read it right. Sometimes the values won't be given. You have to take the shorter measurements. So when we are shifting the viewpoints, that we are looking from this angle, we'll get a different value. Okay. So these type of errors can happen. That is a parallax error, and that is nothing but a classification or a gross error type. Okay. So that is the third classification of errors, which is gross error. So this is human errors because of the human or the person who is taking the reading, he has done something wrong. Okay. So that is the third classification of errors. The fourth classification is systematic errors. So in this systematic errors, this is actually happening due to the wrong way of taking the observation. It can be due to the problem in instruments, or due to environmental variations, or due to the observation, wrong way of observation. Okay, same as parallax error. Okay, so the first one is instrument error. Consider that we are going to use a ammeter. Okay, so this ammeter has a needle, and we all know that before taking the measurement, it has to achieve the steady state or the zero deflection point. Then it goes to positive or to negative, right? But consider that your ammeter is never showing the zero deflection point at the steady state. It will be always shifted to the negative end. So what will happen when we are using this type of an ammeter? It is always shifted towards the negative end, even if in the steady state, even if when we are not using the instrument. Means when we are taking a measurement with this instrument, our measurement will always be some point changed or wrong, right? Some error will be always there because of the problem in the instrument. So this type of errors are called instrumental errors. This is coming under the classification of systematic errors. Okay, so that is one type which is due to the instrument. It can be due to the misuse of the instrument, or it can be due to some friction, or that the instrument is very old, or due to the wrong way of constructing the instrument. These are actually type of instrumental errors which are coming under the classification of systematic errors. Then the second one is environmental error. That is, consider that we are going to measure up pressure. Okay, in the experiment we are going to measure pressure, but we are conducting the experiment in a place where the pressure is varying continuously. Means our observation result can go wrong. So same in the case of humidity, temperature, all these are environmental things. Okay, so if there is variation in the temperature or pressure or humidity, or consider that there is some electric field or magnetic field present around the experimental setup, so then these things can affect our experimental readings, and this will lead to some errors. Okay, so this type of error is called environmental errors. Then the third one is observational errors. So this observational error means we are going to make the reading, but there is some problems with the reading which we take. Again, we can think of parallax errors in this classification or in this category. Okay, so these are the three type of systematic errors: instrumental, environmental, and observational. Okay, so here these errors are actually happening because of the wrong way of taking the measurement, due to the problem in instrument, or due to the problem in the surroundings, which is the environment, or due to the problem in the observation way of taking the measurement. Okay, so these are the fourth classification, which is systematic errors. The fifth classification of error is random errors. So here something random or something unpredictable is happening in your environmental setup or in your experimental surroundings. Okay, consider that there is sudden lightning or thunder or sudden noise is happening, or some you are actually observing some waveforms or sound waves. In that case, some vehicles are passing through, or you are not expecting that thing, but something unexpected is happening. So these type of unexpected things or random things will lead to the random errors. Okay, so these are the 5 classification of errors. The first 2 classifications we were discussing in a numerical point of view. The first one is static error, which is actually not any type of error, but we are actually discussing it in order to discuss the questions, the numerical questions. Okay, that is the first one, static error. Then we have discussed about the limiting error, which is the maximum deviation that can come, and we have also discussed about the relative limiting error. Then we have discussed the gross error and systematic error, and the fifth one is the random error. So these are the 5 classification of errors. So we have discussed the topic errors in instrumentation in a pure exam point of view. We have mainly discussed all the important areas from where the numerical questions can come. Okay, so I really hope that for those people who are especially preparing for competitive examinations, this video will be useful. If yes, please do give it a thumbs up and also share it with your friends. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.